Um, okay, so for today, we're going to look into the chapter 4, circuit theorem. So this one is also very important topic for the circuit analysis. Um, if you're having difficulty to listen or to see my slide, just let me know, because I cannot see your face, so I cannot predict your situation, your mood. Okay. Okay, let's have a look. Okay, last time you already looked into the Ohm's law, Kirchhoff voltage law, Kirchhoff current law, and series resistor, parallel resistor, how to do the calculation. And then you're also looking into the voltage divider, current divider, and then Y to delta transformation. I hope you can still remember all of this. I'm hoping you still remember all of this. Voltage divider, current divider, and Y to delta transformation. And then we also in the chapter 3, last week, I think, last week, we look into this thing, node analysis, super node, and these two I skipped the lecture, but actually you can still have a look into the node and try to understand. And if you have difficulty to grab what is it, just PM me, just contact through WhatsApp. But this topic will not be in the final exam, but it might be helpful if you know about this mesh analysis later on in when you go into the work. Okay. All right. So for today, we're going to look into the chapter 4. So chapter 4 will consist superposition topic, linear property. Actually, linear property is just the base which relate to these two. Okay, so first we look into the linear property, and then superposition and source transformation. Okay, and this source transformation actually relate to these two, Thevenin theorem and also Norton theorem. Maybe you still never heard of it probably. So this is source transformation is a basic for Norton theorem and Thevenin theorem, and also so all of this actually is similar to the chapter 3, which is will help you to simplify the circuit. So previous chapter, which is method of analysis, is help you to do the analysis, right? Your nodal analysis, mesh, but in this topic, in chapter 4, it teaches you how to simplify the circuit. Let's say you got some circuit, then how you simplify it to in order to help you complete your analysis. Okay, so first let's have a look into the first part, which is a linear property. Okay, so this one actually in this world actually we got linear and non-linear, right? And of course you know what is linear and what is non-linear, right? So linearity of the property, we can consider it as a element describing a linear relationship between cause and effect. for example, time and distance. If over the time the distance increase linearly, then we can consider it as a linear. Okay, but let's say over the time the distance change not linearly. Probably for 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 1 minute it changed rapidly, and then for the second minute or probably a third minute it's increased slowly, and sometimes just constantly. So this one we might consider it as a non-linear relationship. Okay, but in this topic I just want you to grab what is meant by a linear property, linearity of the property. Okay, so for example, in electrical world, linearity of the property, we can consider it, for example, if the input is a voltage excitation, for example, if the voltage, for example, we multiply by one constant, for example, you multiply by 10, then that means the output, the response should be multiplied by the exact value, by the same constant. If you multiply by 10, then the response also multiply by 10. That's we can consider it as a linear. Okay. Okay, so the linear circuit is output will depend on the input linearly. Okay, so a linear circuit is one whose output is linearly related, or directly proportional to its input. Okay, for example, in this case, we can consider this as a linear circuit when if we increase the value of the current. For example, we in one circuit we have say we got the resistor for one value. So then if we provide the current, okay, the current source here, we don't know the value, but if we vary the value of the current that passing through the resistor here, then if this resistor is in linear property, that means the voltage also will increase proportionally with the current. Okay, so this is, for example, so you will have a straight line graph. Okay, you will have a straight line graph. So that, but if you look, but actually in the real world, in the practical world, actually resistor not really a linear property, because what because some resistor actually is depend on the temperature. So as the temperature increase, it sometimes is probably causing the resistor to increase its value. That's why when you do some testing in the laboratory, or when you do some project, for example, in order to get the very reliable result, then you will need to run that system for certain value of time. For example, for your final your project, for example, you already built the circuit, then you want to take the value, right? So when you give the power, you cannot instantly take the value after you give that circuit power. You have to wait for a certain amount of time, probably 2 or 3 minutes, until your system reach steady state value, and the temperature reach the steady state value. Then you will get the reliable result for example, your current and the voltage. something like that. Okay. Okay, in terms of linearity of the property, if you look into the power, okay, so this is P is a power. Eh? Power is not a linear property because it's you cannot get a straight line value for the power. It's always a curve value. Okay, so just for the voltage and the current only for uh, that we can consider in linearity of the property. All right. Okay. So a linear circuit is one whose output is linearly related or directly proportional to its input. So this one is like last time I mentioned in the earlier part of this slide. Okay. So the relationship between power and voltage or current is nonlinear. So power is not linear. Okay, it's a non-linear. So in practical, R is not always linear. So resistor changes with the temperature. So the value of resistor actually will vary with the temperature. That's why you always need to, when you give certain amount of current into your circuit, you have to wait for certain time to get your component warm, and then you will get a proper value. That's why when you do the testing, if you test immediately, then this time you get this value, and then when you do another time testing, you will get another value because your system is still not reached a steady state. Okay. Okay, so this one is good. Okay, then the second part, the superposition. Okay, so that before this we look into the linearity of the property. That's the definition. Okay, so for the superposition principle state that the voltage across, or so when we say the voltage across, that means if we have resistor, so the voltage across is voltage across this resistor, okay, or current through, current that passing through the resistor, current through an element, maybe resistor or inductor, in a linear circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. Okay, so this is the concept of the um, superposition. Yeah? If you find it difficult to grab the information, just interrupt me, just ask. Okay. Okay, that's mean in superposition principle, if you have two or more source in your circuit, for example, the voltage or current in the circuit element equals to the total of independent source acting alone. So this idea of superposition, which it depends to the linear property. Okay, that's why we first thing we look into the definition of the linear property. Okay, so two things you have to consider in your mind when you want to do the superposition. First, you have to consider one independent source at a time. So that means if you have many voltage or current source in your circuit, then when you want to do the analysis, you have to select one independent source, and then the other you have to turn off. And then the second one, dependent source are left intact. Okay, so in this case, for example, if you have the voltage source, okay, and then you have resistor, for example, and then you have resistor again, and then you got current source like this, okay, Then if you have, so in the superposition, it's mentioned that if you have two or more source in the two or more voltage or current source in your circuit, then you have to select one uh, at a time. So that's mean if you have two, for example, then you have to do two analysis, which is one at a time for each source. Okay, for example, if you got this voltage source, and then this one is current source, so you got two uh, two step of your analysis. First for this one, and then for this current source. Okay, so when you mentioned that, for example, if you want to do the analysis for this, for the first source, this one for voltage source, and then the other source should be turned off. What is meant by turn off? Uh, for the voltage source, you have to short circuit. If you got voltage source like this, for example, if you got a voltage source, then if you want to turn it off, you have to short circuit this. That's mean in the circuit you have to short circuit. For the current source, you have to open circuit. Open circuit. It will be open circuit. Okay, maybe you still cannot understand it, but it's okay. We will go into the example. Okay. So keep in mind that superposition is based on the linearity. So it's not applicable to the effect on power. So if you want to calculate power, then not for the superposition concept. No, if the power value is needed, then the current through or voltage across the element must be calculated first using superposition. Okay, that's mean the element value you have to calculate it and then return the value back to the return the circuit back to the original then. Okay, the original state, and then after that you can calculate the value for the power. Okay. Okay, so this is 4 step when you want to do the analysis in superposition. Okay, 4 step. Turn off all sources except one. Okay, and then the second one you have to solve using a simple technique, any technique in electrical, and then repeat for the other source. Okay, and then after that you have to add the contribution. So please remember all 4 of this. So this step is very important step for the superposition. Okay, for example, if you got this superposition theorem, find the V value. So you need to find the V value for this. Then what you need to do is you have to select either this one first or this one first to do your analysis. Okay, so you can select any. Okay, Afifi, which one you want to select? So let's say, for example, if you want to select this one first for the analysis, then the other source you have to turn it off. Okay, so if you select this one, your circuit will be like this. You still have the voltage source 6 volt, and then you still have the resistor 8 ohm, and then you still have the 4 ohm resistor. Okay, and then for your current source, it will be open circuit, normal current source. So from this, then you can do your calculation. you can find the voltage here. Let's say V1 for example. Okay, and then when you select for this one, for the second source, then your circuit will be, your voltage source will be short circuit. Okay. This is 4 ohm. Then this one is V2. We want to find V, so that's mean the voltage value you get in the first one here, V1, and the voltage value that you get from V2 here in for the second part, you have to total it. So V here will be V1 plus V2. Okay, so that's why we call it superposition. Okay, this is 3M. Okay, so let's do one by one. Let's say we do this one first. Okay, so actually it's not that difficult, right? If you want to get the V1, actually you can do the um, voltage divider. Okay, let's say we do the voltage divider. Actually V1 here will be um, uh, 4 divided by 8 plus 4 times with 6 volt, right? 4 ohm for this one, 4 ohm divided by the total resistor here. And this one actually we can just ignore it because actually it's open circuit. It's like no more here. Okay. Okay. So what is the voltage for V1? Norin, boleh dapat? Yunis, can you calculate this? 4 over 4, 8 plus 4 is 12. 4 over 12, right? 4 over 12 times 6. So 1 and 2. 4 over 2 is 2 volt. So you get V1 is 2 volt. That's one method. And then another method, you can also use Kirchhoff voltage law to determine the V1. Okay, but I will not discuss here. We try to save the time. But you can try this method as well. You can to determine V1. Okay, okay. So the first one we already have. So actually V is V1 plus V2. So V1 is 2 volt, and then V2. Let's try to find V2 here. So for V2, you got the current source. Okay. You can solve using a current divider. Okay, current divider. So for the current divider is so this one is voltage divider. Voltage divider method. So for the current divider method, it will be, let's say if you have a current source, for example, and then you have like this one in parallel, right? R1, R2. Okay, then this one is I. So the equation will be, if you want to find the I1 is equals to R2 divided by R1 plus R2 times I. Okay, can you all grab this? So this is the equation for the voltage divider. Okay, okay, so that's mean for this one, if you want to get this current I, so I will be 8 divided by 8 plus 4 times with 3 ampere current source. So 8 over 12 times 3. This one will be 1, this one is 4. 8 over 4 is 2 ampere. Okay, you get 2 ampere, but you don't want the current here. You want the V2. So actually V2 is equals to 4 times 2 ampere. Okay, you got current, you got the resistor 4 ohms, they just multiply IR, right? V equals to IR. 4 times 2 is 8 volt. Okay, V2 is 8 volt, so 2 volt plus 8 volt will be 10 volt. Okay, so this is the answer for the V here. Okay, you understand? Amirul, Azino, Afifi, okay tak?
Okay, sir.
Alright, Yunis, okay, you okay?
Yes, lecturer.
Okay, okay, alright. Alright, so this is the example 4.1. Let's have a look. Okay, so I cram into only just one pages. Okay, so maybe I just delete this too. Okay, okay, so let's try the example 2. Okay, so example 4.2, actually the same, a similar circuit to the first one. So you same method, you have to decide. The first, you have to select one source, and then the other source you have to turn it off. Okay, then do the analysis, uh, and then after that do the second one. So for example, this one, let's say I choose this as a first one, and I choose this one as a second one. Second one. So then first, the easiest part is to draw the circuit first. Okay, let me right. You want to get the V out here. Okay, so draw the circuit, and then for the current will be open circuit. So just leave it open. Okay, this is 12 volt, 5 volt, 3 volt, and 2 ohm. 5 ohm, 3 ohm, 2 ohm. Okay, so you want to find the VO here. VO here. Just use a voltage divider. Okay, I think it's very simple uh, solution. So VO1 is, so VO here will be VO equals to VO1 plus VO2. So let's say this one is VO1. The second analysis will be VO2. Okay, so VO1 will be 2 divided by 2 plus 3 plus 5 times 12. Right, so okay, berapa? How much? Afifi, Yunis? So this one will be 2 over 10 times 12, right? So this is 6, this is 5. 2 times 6 is 12 over 5. Okay, so this is 12 over 5 volt for the VO1, and then for the VO2, if you draw it, you will get something like this. Okay, this is 5, this is 3, this is 2. Actually 5 lah. Then you want to find the value for this. Okay, I think this one you cannot use current divider. Actually, you can get the value for the voltage here. You can use a current divider. You can use a voltage divider. No. Current divider to find the current here, or to try to find the current here. I1. Once you get the current here, then you can get the voltage here. Okay, the voltage VO2 is equals to resistor here multiplied by I1. So the current is 5 amp. Okay, so current divider can use current divider. I1 equals to 5 here divided by the total resistor all 5 plus 3 plus 2 multiplied by 5. So this one will be 5 over 10 plus multiplied by 5. So 1 and 2. So you get 5 over 2 ampere. So this is the current that passing through this resistor 3 ohm and the resistor 2 ohm. So from this value you can get the VO2 equals to I1 times resistor 2 ohm. 2 ohm. So this will be 5 over 2 times 2. Cut, you get 5 volt. 5 volt. So then after you can sum it. Okay, VO1 will be 12 over 5 plus 5. Okay. Okay, so how much the resistor value? Okay, the resistor, the voltage for all. Okay, this one 12 over 5 is 12 divided by 5 is berapa? 12 divided by 5. I forgot to bring the calculator here. Maybe we can just make it 12 over 5 plus 25 over 5. So we get 37 over 5 volt. 37 over 5 is calculator. Okay. 37 divided by 5. 7.4. Okay, so you got 7.4 volt total. Okay, understand? Boleh ya? Alright. So if you keep quiet, then I assume that you all understand this. Alright. So this is the second example. Okay, for this. Okay. Okay. So this one I want you to do it as a tutorial. So I'll actually this slide already put into the author. So you can download it and then you can do this tutorial. I think there are 3 or 4 tutorial for the chapter 4 for you to do. Right? Okay, so then the third subtopic. Okay, so now we already look into the superposition, and then now we look into the source of transformation. Source transformation. Okay, why we call it source transformation? Actually, we can transform if, let's say, if in our circuit we have a voltage source with a series with the resistor, then we can transform it into the current source and that are parallel with a resistor. For example, let's say I got like this. I have this voltage source, let's say 2 volt, 2 ohm, and then I have many other circuit here, resistor for example, like this. Okay, let's say 2, 8 for example. Okay? And then this one you can transform into this one, into the current source. Okay, so that's why we call this source transformation. Actually, this topic will help you in the Thevenin theorem and also Norton theorem later on. Okay, so source transformation is the process of replacing the voltage source in series with resistor by a current source in parallel with resistor, vice versa. This is for it's like a tools help to help you to do the analysis. Okay, for example, we got like this, then we can transform it into the current source like this that are parallel with um, uh, current source. Okay, this value we have to calculate IN and then RN. Okay, so this is 2 and 8. Okay, so this is remain the same. This one will remain the same, but this one there is a formula to determine the value, and that will be comparable to above circuit. Okay, so that's why we call it source transformation. Okay, for example, use so this is the example 4.3. It asks us to transform the circuit to find the VO value in the circuit. So you have to do the source transformation to what you call it to simplify, because sometimes in this kind of circuit it's a little bit complex for us to do our analysis quickly. So then it's easier to change to transform the circuit, this one, into the voltage source that are series with voltage source. So that's mean from here, this part, current source and the resistor, we can change into the voltage source like this. Okay, like this. So this means you remove this and then you replace with this into here. Okay, so that's why we call it source transformation. Okay. Okay, so let's see how we solve this. All right, let's have a look now. Okay, so this circuit, okay, this one we want to change to the from current source that are parallel with this is 4 ohm and 3 amp. We want to replace into the voltage source V and then resistor. So how can we determine this? Okay, let's do it. So first we need to determine the value of the resistor, the voltage. So the voltage is if we look into this one, okay, Um, if we look into this one, the value of the voltage here, P here is um, P equals to 4 times the 3M, P equals to IR, okay, 12 volt. Okay, and then for our resistor value, we can use the same value, right? We can use the same value, 4 ohm. I equals to, wait, no. Okay, so we can remain this value 4 ohm. So R will be 4 ohm, and for the voltage we can just multiply for the resistor with the current. So we get for 12 volt. Okay, so then you can just transform your circuit into this value. You got 12 volt, and then you get 4 ohm. Then you remove all of this, and then you put the remaining element in the circuit. Okay, like this. 3 ohm, and then you got 12 volt here. Okay, and then for this one, actually, okay, and then at the back here, you have to change this to the current source. Okay, so you have to transform this into the current, transform this into the current, like this. Okay, so you have uh, R and I here. So how to do it? You have 12 volt and you got 3 ohm. Okay, so that's mean for the current will be I will be V over R, 12 divided by 3. 12 divided by 3, you will have 4. So this means your current is 4 ampere, and then your resistor here will remain the same. Just bring it here in. So that's means let's draw again. So if I draw again, you will have you have 4, you have 2, okay, this side 12 volt, and then you will have 8 ohm here, and then after that 3 ohm. This resistor you bring into parallel circuit, 3, and then you will have like this 4 ampere current source. Okay, so this one, the circuit will transform into this kind. Then you can do the analysis for this. Say this one you can combine. 4 plus 2 is equal to 6, right? So this is minus 12 volt. So you will have 6, you got 8 and 3 also you can combine this. But let's do one by one. This one 8, this one is 3, And then you have current source 4 ampere. Okay, so from this actually we can do transformation again into the current source. Let's try to do the transformation again for the current source. Change this. If we draw again, it will be like this. If we have current source, and then 6 ohm resistor will be here in parallel. Then you get 8 ohm resistor, 3 ohm resistor, and then you will have 4 ohm current source. And this one, this is 6, 8, and then 3. And for the current source here, you have to determine it. I equals to V over R. Okay, 12 divided by 6 lah. 12 divided by 6, which will be 2. So you have 2 amp. 2 amp. Okay. So then after that, I think from here you can actually determine the value for the V out, because V out is at the here. But you can also what we call it, this parallel, this all these three resistor, you can combine this. You can find the R equivalent for all these three. Let's try to determine. So 1 over R equivalent is equals to 1 over 6 plus 1 over 8 plus 1 over 3. Yeah. So from this you will get how much this one? Okay, I think for the current source also you can combine this. You can combine. Let's first combine the current source instead of combine the resistor. So if we redraw again, you will have 2 ampere plus 4 ampere. You will have 6 ampere current source. 6 ampere. Okay, and then 6 and then 6 and 3 ohm resistor. If you do the parallel resistors equation, you will have so 6 and 3, 6 and 3 are equivalent. This one you will have 2 ohm, 2 ohm resistor, and then parallel. So this one 8. So 8 ohm resistor we cannot combine with other resistor because we want to find the V out here. Okay, so it's need to be remain in on its own. Okay, so from this you can do the current divider to find the value of the current over here, I for example. So if we do the current divider, um, I equals to 2 over 2 plus 8 times 6, right? 2 over 10 times 6, 3, 5. 2 times 3 is 6 over 5. 6 over 5 is 1.2 ampere. Okay? You get 1.2 amp. So 1.2 amp Then from this you have what you call it, the, when you get the current here, then you can find the V out equals to 8 times current 1.2. Okay, so then you get the voltage lah over here. Okay, so this is the V out. Okay, alright. Any question up till now? Okay, I think Noreen can left if you want. Noreen already left. Okay, so she left already because she got a test. Yes. Alright. Okay, so done with this one. For the what you call it? I think I made mistake here somewhere because this current is to the bottom and this one is to the top, right? So that's mean I got the wrong value. Let's have a look where I made a mistake. Because for the source transformation, if your voltage is reverse, for example, this one, if your voltage is plus minus plus like this, then here also you will have the direction of the current will be reversed. So that's the thing that you need to consider. You have to make sure that so that's mean in this case, in this one, actually the your voltage for this one is not like this. It should be reverse plus minus of this. Okay, so when we do another transformation, okay, this one also I need to remove minus plus. Then when we do the current transformation, this one will be reversed as well. It will be to the bottom. That is okay. So when we want to add, we cannot just add like this one. Actually, 4 plus minus 2 lah. 4 plus minus 2 will be 2 ampere actually here. Okay, sorry. So 2 lah. So that's mean this value will have a different value. Let me delete first, sorry. 2 over 10 times 2. 5, 1, 2 over 5. So 2 over 5 will be 0.4, I guess. 0.4. 0.4. So 0.4 times, sorry. 0.4 times 8 is equals to 0.4 times 8, 3.2. So you will have 3.2 volt. So this is the V out. V out here. V out is equals to 3.2. Okay. Try to do it again. So you all can try do it. Otherwise, you will not be able to grab this. You will not be able to understand how this source transformation, how you solve this circuit using a source transformation. So actually, you can just transform. So in this example, we do a twice transformation, right? So from the first one, first we change from the current source and the resistor in parallel into the voltage source, which series in the resistor, and then after that we combine 4 ohm resistor and 2 ohm resistor, and then convert again into the current source, current source here. Then after that we uh, we combine both current source that we got to simplify the circuit. So this is one of the method how we simplify our circuit from this one, from this, from this into this one, the simple one. You have a current source and only two resistor in the circuit. From how many elements here? 1, 2, 3, 4, 5, 6. 6 into 3. So much better, right? Okay. So this is what we call a source transformation. Okay. Okay. So this one also you have to uh, copy this question and do it as a tutorial. So you got the second tutorial here. Okay. Actually, don't worry if it's difficult, because actually it's also got the answer. So, but I just want you to do it again and try to understand how to solve this problem. Okay, then so this is the second tutorial. Okay, then we look into the Thevenin. Okay, so in electrical circuit theorem, we got two theorem, a Thevenin theorem and also Norton theorem. Actually, both Thevenin theorem and Norton theorem are related to the source transformation. So for the Thevenin, it's focused on the equivalent circuit, which consists a voltage source that series with the resistor. Right? And then for the Norton theorem, another theorem, Norton theorem, it consists the equivalent circuit that relate to the current source. Okay, so Thevenin theorem with voltage source, voltage source and resistor, and then we also have a Norton theorem. Norton theorem is more related to the current source, which are parallel with resistor. So both Norton and Thevenin theorem actually is depend on the concept of depend on the principle of source transformation. Okay, so let's have a look into the Norton Thevenin theorem. So in Thevenin theorem, actually we can say a linear to terminal circuit can be replaced by equivalent circuit consisting of a voltage source and a resistor in parallel. So this is for the Thevenin theorem. Okay, so let's say if we have a linear two terminal circuit, then we can replace with the Thevenin. That means we can simplify it. So this is the way how we simplify the circuit. Okay, so this is how you in Thevenin theorem you can if you have a circuit, then first you have to remove the load in order to determine the resistance value of the Thevenin RTH. And then you have to turn off the voltage source or current source. Then after that you can calculate the resistor for the Thevenin. So this is for the RTH, for the resistance of the Thevenin circuit. And then for the voltage from the terminal AB, you just have to remove the load, and then you have to find the Thevenin voltage, the open circuit using various method that you already learned previously. Okay. Okay, I think it's easier if you look into the example. Right. Uh, okay. So this one. Find the Thevenin equivalent circuit eh, of the equivalent circuit of the circuit to the left of the terminal AB. So this is terminal AB. Okay, so this one we can consider it as a load, eh? As a load. Okay. Then find the I. So then you have to find the I. So the first thing you have to simplify this one. So that means from this circuit you have to change into, okay, you got a load. Okay, this load is this one. Okay. Okay. Then here you have to change into this kind of circuit, RTH and then VTH. Okay, so from this circuit you have to transform into this circuit. Okay, so you have to do it step by step. Okay, okay, how to do it? Let's see. Okay, so if you look into the method, okay, first you have to determine the RTH. Okay, let's determine the RTH. So the method to determine the RTH is first you have to remove the load from the terminal. Okay, first you have to remove the load from the terminal. So please remember, remove the load from the terminal, and then the second one you have to turn off the voltage source or current source, and then calculate the RTH from the terminal AB. So let's draw it first. Okay, so this circuit, let's draw it from AB side. So first method is uh, remove the load. So you have to remove the load. Okay, let me draw it again. We got 6 ohm, and then A. Four ohm, and then this one 6 ohm, 12 volt, and then 2 amp. Okay, so this is B. Okay, so first you remove the load. Okay, I already removed the load. Okay? And then the second one you have to turn off source. Okay? Turn off source. How to turn off the source? For the voltage source, you have to short circuit it. For the current source, you have to open circuit. So let's redraw again. So current voltage source, it will be short circuit, and then for the current source, it will be open circuit. Okay? 4, 6, 6. This one will be BA. Okay, so then after that, you can determine the RTH, which is equivalent circuit for this. So 6 plus 6 will be 12, right? So your circuit, if you simplify, it will be like this: A, B, 4 and 12. So RTH will be 4 parallel with a 12 ohm resistor. So 4 and 12, you will have how much? Let's calculate. 1 over RTH equals to 1 over 4 plus 1 over 12. So 1 over 4, you make this one denominator same. So 4 times 3, this one times 3. So 3 over 12 plus 1 over 12. 4 over 12, 1 over 3. Okay, so 1 over RTH will be 1 over 3. So, RTH is 3 ohm. Okay, so you get RTH is 3 ohm. Okay, so this is the value for the RTH. So if you draw the circuit again, I'll just simplify circuit, plus minus VTH and then RTH, and then you have 1 ohm here. So RTH will be 3 ohm. Right? RTH will be 3 ohm. 3 ohm, 1 ohm. Now you need to determine the VTH. Okay, so let's see how we determine the RTH. So for the VTH, from the terminal AB, remove the load and then find the VTH or V open circuit using various methods. So first we need to draw the circuit again. We have plus minus 6, 6, 4, A and B. Okay, so you need to determine the VTH here. In order to get the VTH, you have to do uh, the nodal analysis that you learned previously in the chapter 3. Okay, so let's say this one is V1 and this one is VTH. Okay, VTH over here. Okay, so you will have I1. This one is 2M. This one I2, and then you have I3 here that passing through the 4 ohm. Alright, so for the node 1 V1 here, the KCL, Kirchhoff voltage law, will be I1 plus 2M equals to I2. Okay, current in equals to current out. Okay, here. So I1 is how much this one? 12 volt. 12 minus V1. Okay, this one minus this, you will get the voltage for the 6 ohm resistor, and then divide by 6, you will get the current. So this one will divide by 6, you will get the current I1. And then plus with 2 ampere equals to, for the I2 is V1 minus VTH. This one divided by 6. This is for the I2. Okay, so from this, you can remove the 6 by multiplying it with 6. So you will have 12 minus V1 plus 12 equals to V1 minus VTH. 12 plus 12 is 24. Minus V1, if you move into the other side, it will be 2V1 minus VTH. Okay, so this is the first equation that you have. Then you have to do the analysis for this node VTH. VTH. So let's just do another one. Current in equals to current out. Okay. So actually I2 equals to I3. Okay. So this one for the node VTH. Node VTH. I2 equals to I3. I2 is V1 minus VTH divided by 6 equals to I3 is VTH divided by 4. VTH divided by 4. Okay, so done with this one. So first you have to multiply by 12 in order to remove the bottom part. So so this one you will have 2V1 minus 2VTH equals to 3VTH. So from this you can move this one, this minus 2VTH into the other side. 2V1 equals to 5VTH. Okay, so this is the second equation. Okay, so from this actually you can move this one into here. You can equation 2 into equation 1. 2V1 you can put here. So that's mean you will have 24 equals to 2V1 equals to 5VTH. So 5VTH minus VTH. This one will be 4VTH. Oops, 24. So VTH equals to 24 minus 4. 24 minus 4 will be, how much is it? 6 times 4, 24. 6. So you will have VTH equals to 6 volt. Okay, that's mean let's add another page. Duplicate. Okay, so the circuit, if we redraw it, that's okay. So if we redraw it, the Thevenin circuit is a load 1 ohm, and the value for the resistor is 3 ohm. RTH is 3 ohm. VTH is equals to 6 volt. Okay, so from this, when the question asks you to determine the I here. So of course you can just get the value for I. So I equals to V over R, right? Where V is 6 and then R is the total of the resistor in the circuit. So 3 plus 1, 6 over 4. So then you get 3 over 2 or 1.5 ampere. So this is the value for the current. Okay. So up till now, everyone okay? You all still follow me, or you lost already? You lost in the jungle. So
Still
this is
follow,
for the,
betul.
okay. Can follow or cannot follow? Can't follow.
Boleh, boleh, boleh.
Boleh okay. If you can't, if you find it difficult to understand, you can always try it first. Then just PM me. Just WhatsApp me the question, the part that you can't understand. Then I can always help you. I can just draw on the paper and explain it to you. But please do it first. Otherwise, you will not be able to test this. Anyone can hear? Can you hear? I just suddenly
Yes,
everything.
yes,
Okay, okay. Alright.
we can hear.
My my PC suddenly hang and everything stopped. So that's why I try to ask you again. Okay, so now we look into the Norton theorem. Actually, uh, both Norton theorem and Thevenin theorem actually is a similar concept for the electrical analysis. Is to simplify the circuit, but Norton theorem focus on the current, eh? the current source that series with the resistor, while for the Thevenin theorem is focusing um, uh, on the voltage source that is series. Norton theorem is current source that are parallel with the current source, while the Thevenin theorem is focusing on the voltage Thevenin source that are series with the resistor, the series resistor. So both Norton and Thevenin theorem both are uh, closely related to the source transformation, which you learned previously, in the previous topic. Okay, so let's have a look into the Norton theorem. So uh, I think we just actually the concept on how to solve the problem is closely similar. So actually we just directly look into uh, the example. Okay. Okay. So let's say we have this. Okay. We have uh, this circuit. So it's us. Uh, the question is find the Norton equivalent circuit at the terminal AB. So that's mean for this circuit you have to transform into the current source which are parallel with the uh, Norton resistor, Rn, and then In. Okay, so you have to simplify the circuit from this into this one. Okay, so the method on how to do it is first you have to remove the load. Okay, of course the load already, there is no load in the circuit. Okay, and then after that you have to turn off the voltage source and current source. This one is to determine the Norton resistor. Yeah. And then you calculate the equivalent of resistor. Eh? So okay, on the other hand, in order to determine the current source for the Norton theorem, you have to short circuit this AB, terminal, and then after that solve the IN using the short circuit current. So the current that passing through the AB, we call it Norton current. Okay. Okay. Let's try to do it. Okay. First, we find the Norton resistor. So for the Norton resistor, you have to turn off all the source. Okay. Redraw back circuit. So for the current source, it will be open circuit, and then for the voltage source, it will be short circuit. Okay. It will be short circuit. You have another one here. 8, 5, 8, and then 4. Then this one is terminal A and B. Okay, so then you can simplify this. So this is Rn over here. Okay. The way you look from the terminal AB. Okay, so I think resistor A, 4 and 8, you can just sum it. Okay, so it will become 8 plus 8, 16, 16 plus 4 is 20. So it will be 5 and 20. So this is Rn. So Rn will be 5 parallel with 20. Okay. So how much this one? Can you determine this? 5 parallel with 20. How much, Amirul? Can you calculate this for me? One over Rn equals to 1 over 5 plus 1 over 20. This one times 4 times 4. So it will be 4 over 20 plus 1 over 20 will be 5 over 20 will be 1 over 4. Okay, so Rn actually is 4 ohm. Okay, so Rn is 4 ohm. Okay, this one. Okay, that's for Rn. Then you need to determine the In. So in order to determine the In, you have to use this method. Short circuit determiner AB, and then solve I short circuit will be equals to In. So you have to redraw again. Redraw your circuit. It will be like this. Source to have 4 plus minus 12 volt. This one is 2 ampere, 8 ohm. Then you will have 5. This is 8 ohm. So and then you have here short circuit here. This is In. Okay, you need to determine In over here. Okay, so for the In, you can do short circuit. Right. So if this one there is a short circuit here, automatically we can the current. If the current here, let's say your current here is 5 ampere, and then it got two road, right? I1 and I2, for example. This one is short circuit, and this one got a resistor. Automatically, all the current here will go to I2 instead of I1. So I1 is, so that's mean I1 you can just eliminate this one because the current will not pass through here. So automatically the voltage also will be zero. When the current is zero, I1 equals to zero, then the VO also zero. So this one we can remove this. So then you can redraw again the circuit. You will have like this. So this one this one 8 ohm, this one 4 ohm, this one 8 ohm, and this one 2 ampere source, and then 12 volt source. Okay. Okay, so from here to here, everyone okay? Can do you understand why we have to remove the resistance 5 ohm? Okay. So when I assume you understand this, all right? Okay, so once you get this, then you can do the analysis. So let's do the first loop I1, and then the second one I2. So we can do the analysis for this. So for the I1, it will be uh, okay, right. Okay, let's try to do I2 first. I1 is minus 12. Okay, so for the voltage here, for this loop, for this loop is minus 12 plus. Eunice, can you turn off the mic? Can you accidentally on the mic? Okay. 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 If you have minus 12 volt and then times with 4i2, 4i2. Okay. Again 4i2 and then minus okay, minus I1. Sorry. Plus minus 4i1 plus 8i2 plus 8i2. Okay, so we got here. So for this, we got I1 here, and then I2. Yeah, so that's why for the voltage, we have to determine, we have to calculate for I1, resistor for I2 times 4, and then minus by I1 times 4. So we get the voltage across the resistor 4 ohm, and then I2 times 5 times 8 ohm resistor here, and then I2 times 8 ohm resistor over here, down here. Okay, so then all of this will be equals to 0. Okay, so from this, you can simplify your circuit here. I think minus 12, you can move to other side. 488 is 20i2 minus 4i1 equals to 12. Okay, so this is the one equation. And then for I1, actually, I1 is equals to 2 ampere. It's always 2 ampere because you already have the current source here. So you exactly know the current I1 is equals to 2 ampere. Okay, so that means you can replace I1 into this here. So 20i2 minus 4 times 2 will be equals to 12. Okay. Okay, then from here you 20i2 will be equals to 12 plus 8, 20. Okay, so that's mean I2 will be equals to 1 ampere. You have I2. And you know that IN, this one, I Norton is equals to I2, which is 1 ampere. Okay, so this means your circuit, the one that you want to draw. Okay, so Rn is equals to Rn equals to 4, and then for the In is equals to 1 ampere. Okay, so that's mean then after that you can redraw your equivalent circuit 4 and 1. Okay, so that's mean here is 4 ohm, and then In is 1 ampere. Okay, so done with the Norton theorem example. Okay. Okay, then we have another one. This one I will just keep, but you can do it later on. So same with this one. So for the circuit, you have to find the Norton equivalent circuit, uh, which is IN and also RN. So use the same like the previous method, right? So first get Rn. I think for Rn you can just, this one will be open and this one will be short circuit. So then you can get your equivalent Rn. I think if you look into here, uh, for the Rn it will be, for the Rn, if I draw again short circuit, uh, 3 3, and then get 6, then you got AB. This is Rn, 3 3 6. So this one, if you simplify this, you will get Rn is equals to 6 parallel with 6. Okay, so 6 parallel with 6, how much? 6 parallel with 6 is 3 ohm. Okay, so for the Rn is 3 ohm. Okay, so then for your IN, you can just redraw again and do the analysis for your circuit. Okay, then you have a current here, and then same for the resistor 6 ohm, you can just eliminate, because when you short circuit the terminal AB, and then all the current will pass through terminal AB instead of resistor 6 ohm. So this one is IN, this is 3, this is 3, and then this is 4 ampere, and then this one is 15 volt. Okay, please remember, I just I think this topic, Norton theorem and also the Thevenin theorem, both of this topic will be in the final exam. Um, so please make sure you try to take note, and then you try to understand how to solve this type of problem. Okay, so from this you can just do the analysis. Let's say this is I1 and this is I2. Okay? I2. So you know the from this you can just voltage is 15 volt. Okay, so for the I1 is negative 15 plus 3 3I1. Okay, 3I1, and then minus 4 equals to 0. Okay, so from this you can 3I1 equals to, oh sorry, for this one, for I2 minus I1 equals to 4. Okay, so this is the one equation, and then the other one is, I think I made some mistake here. Example 4.6. Okay, I think in this case we have to do the source transformation. Instead of using the voltage source, we can just do the transformation into the current source. Okay, otherwise we might find it difficult to solve this part. Okay, because the reason is in here. Okay, when we do the analysis for the current, we start over here. So let's change into the source transformation. We change from the 15 volt 3 ohm into the current source. That means you will have a current source here, and then 3 ohm resistor, and then you will have the current source 4 ohm, 4 ampere, and then we have 3 ohm resistor, then short circuit IN. Okay, so then after that you can just total this. Okay, you can just total for first. Let's find the current over here. Okay, so for the current I here is 15 volt divided by 3. 15 volt divided by 3 will be 5 ampere. So 5 ampere and 4 ampere, you can just combine the source. Okay, because both are going up. Okay, 5 plus. So you can rearrange back. 5 plus 4 is 9 ampere. Okay, then you will have a 3 ohm resistor, and then also you will have 3 ohm resistor. Yeah. So IN 3, 3, 9. So then from this you definitely get your IN using a current divider. So current IN equals to 3 over 3 plus 3 times with 9 ampere. So half of it. So that's mean your current, your IN will be 4.5 ampere. Okay, so this one will be 4.5 ampere, your Norton current. Okay. Okay, so done with this one. So that's mean for the Norton resistor, you just do it like previously, but for in order to find the Norton current, you have to do the source transformation, and so which method to select is you have to do a lot of exercise, and in this part actually, in this slide actually I already provide you with many exercise at the end, so you can try to do it, and then from that you can gain some experience in using different kind of method to solve your your various circuit problem. Okay. Okay, so this is for Norton theorem. So we're done with this part, and then you have a tutorial 3. So for the tutorial 3 is also if you look into the author, actually I already set the the individual activity for you. Okay, so please open your author and then look into the individual activity, and then just complete the exercise. 3 tutorial, I think just 3 tutorial, complete it and then submit as soon as possible. Okay. Um, uh, then okay, the last part in this chapter is maximum power transfer. So actually for the power transfer, so let's say we have this circuit, uh, the voltage source and the current source, the resistor, and then we also have the RL variable value of resistor which we can vary the value. So then from this, if you want to determine the power in that absorbed by the resistor here, RL, is PL. PL equals to I squared. I squared times with R. So I passing through the RL times with the RL. So if you determine the current here, the current the circuit not circuit, the value of the current can be determined by this Thevenin voltage divided by uh, resistance, Thevenin resistance plus the RL. Okay, so this is for the power in the RL. But uh, in order to get the maximum power is the definition of maximum power is transferred to the load when the load resistor is equals to the Thevenin resistor. So this is the concept. Maximum power can be achieved when load resistor is equals to the Thevenin resistor. So that's mean if this value is same as this value, so this resistor value in the load same as the Thevenin resistor value, then we can achieve the maximum power in the circuit. So maximum power is transferred to the load when the load resistor is equal to the Thevenin resistor. So this is the definition of the P max, maximum power, for the Thevenin power, for the Thevenin circuit. Okay. So this is the equation for the Thevenin for the P max. Okay. So please remember this. All right. So when using this circuit, when using this equation, PL equals to BTH over RTH plus RL square times with the RL. When you this one, PL equals to I square RL. Okay, assuming that when you vary the value of RL from this to here, okay, as you increase the value of RL, the graph will increase like this. It will go like this and then it will drop back. And at the middle, when the RL is equals to the RTH, the Thevenin resistor, automatically the value of PL will be max, will go to the top of this graph. Okay, so this is the kind of graph that you will get when you plot the PL against the RL. Okay, so that's it for this chapter 4. Okay. And then I also include in this slide the extra tutorial and exercise, and you can find your own time. Maybe tomorrow you can try to do it and try to contact me if you having difficulty in what's called it solve the problem. Just PM me, just snap the picture or print screen and then just WhatsApp me and then ask me. That's fine. I will try to help you as soon as possible. Okay. So then I think for this subject in the yearly semester I already gave you the group project, right? So please everyone please find your time, spend your time in your group, try to discuss how to work on your project, and also we will have the test 2. Okay, we complete the test 1 already, and I think for your needs you need to provide with the copy letter. You need to photostate and pass it to me, and then you need to also pass me the MC letter, and then after that I will prepare the test 1 if you want. But if you don't want to do the retest for the test one, then that's fine. It's I
Okay, that's
uh,
okay.
yeah, please provide with the documentation, and later on I will prepare for the test one. Because for the test one I cannot use the same question. I need to make the new test question, and then you can do it again. Okay. Otherwise it's not fair to your friend. But let's say, for example, you think it's hassle to do the test. Okay, you don't want to do the test one. That's fine. You can, but the marks for test one, I think 12.5% from the total of 100 for this course. So please consider that. Okay, but if you don't want to take the test, that's fine. It's okay, but you will lose the 12.5 marks. Okay, that's for the test. Okay, I think that's all for tonight. Yes, 10 minutes to 10 o'clock. So we almost 2 hours class. Yeah? I thought we can finish around 9 o'clock, but now already 10 o'clock. All right. So anyone have question? Amirul, Azino, Afifi, Yunis? No question. Okay, I guess most all of you already uh, going into the bed, is it? Okay, so I think that's all for tonight. Thank you very much and have a good night. Assalamualaikum.